Next one is diffusion. Diffusion. Draw the diagram of diffusion charge carriers in a semiconductors. Diffusion of charge carriers. This is the diffusion. Diffusion of charge carriers. Charge carriers. Now this is also diffusion of charge carriers. Figure. This figure is diffusion of charge carriers in a semiconductor. Diffusion of charge carriers. Diffusion of charge carriers. In a semiconductors. Diffusion of charge carriers in a semiconductors. Now discuss about the diffusion. What is meant by diffusion? Diffusion means due to non-uniform carrier concentration. Due to non-uniform carrier concentration. Due to non-uniform carrier concentration in a semiconductor. The charge carriers move from a region of higher concentration to a region of lower concentration. Region of higher concentration to a lower of higher concentration. This process is called as diffusion. Diffusion of charge carriers or diffusion. Diffusion of charge carriers or diffusion. Diffusion of charge carriers or diffusion. Diffusion means due to non-uniform carrier concentration in a semiconductor, the charge carriers move from a region of high concentration to the low concentration. This phenomena is known as diffusion of charge carriers. Now, let delta n be the excess electron concentration, be the excess electron concentration. Let delta n is the excess electron concentration according to Fick's law. Fick's law. The rate of according to Fick's law, the rate of diffusion of electron, the rate of diffusion of electron, the rate of diffusion of electrons, that is proportional to minus tau by delta n divided by delta x. Here that equal to minus dn dou delta n divided by dou x, where here delta n is the diffusion coefficient of electron. Diffusion coefficient of electron. Diffusion coefficient of electron. Next, the diffusion current density. The diffusion current density due to electron is given by here Jn equal to Jn diffusion. Jn diffusion equal to charge of electron equal to minus E, that equal to diffusion formula is dn dou delta n divided by dou x. Next, final one is E dn dou by dou x delta n. Next, the diffusion of diffusion current density due to hole is given by that equal to here Jn diffusion next Jp diffusion equal to charge of hole equal to plus E, that equal to minus dp dou by dou x delta p. Next, that equal to minus E dp dou by dou x delta p for Jp diffusion. Diffusion. Here delta P and dn. Here dp is diffusion coefficient of holes. Diffusion coefficient of holes. Next, that is the total current density. The total current density. The total current density is sum of current densities due to drift and diffusion. That equal to Jn equal to Jn capital J equal to Jn drift plus J n diffusion. Jn drift plus diffusion, that equal to, substituting the Jn drift equal to small n small e mu n e, that is the electron drift, that equal to diffusion equal to small e capital N dou by dou x delta n equal to Jn. Next, similarly, Jp equal to P small e mu P capital E minus small e dp dou by dou x delta P. Now draw the variation of excess electron density. The variation of excess electron density delta n with respect to x is drawn that equal to this is the graph for variation of excess electron and distance in semiconductors. This is the x is delta n. This is the diffusion SiON. This is the diffusion. This figure is carrier diffusion. Carrier diffusion. Here x is the distance in semiconductor, delta n is the excess electron density. Once again, I will tell you what is diffusion. Diffusion means due to non-uniform carrier concentration in a semiconductor, the charge carriers move from a region of higher concentration to a region of lower concentration. This process is called as diffusion of charge carriers. We show the figure. This one is the, we are assuming this one is the higher concentration, this one is the lower concentration. When the charge carriers are moved from higher concentration to the lower concentration in the electric field, in the electric field. Here this one is the diffusion of charge carriers region. This one is the charge carriers are moved from diffusion of charge carriers moved from higher concentration to the lower concentration. This is the electric field. Figure is diffusion of charge carriers in a semiconductors. Next, let delta n excess electron concentration. That is, delta n means excess electrons. According to Fick's law, the rate of diffusion of electrons is, that is, proportional to minus dou by dou x delta n. That equal, remove this symbol, that is the proportionality symbol, that equal to minus dn dou delta n by dx. Here dn is the diffusion coefficient of electron. dn is diffusion coefficient of electron. Next, the diffusion current density due to electron is given by diffusion current density due to electron is given by Jn diffusion equal to charge of electron is minus E, that equal to diffusion of electron is minus dn dou delta n by dx. Final solution is Jn diffusion equal to E minus minus plus E dn dou by dou x delta n. Next, again, the diffusion current density due to holes is given by Jp diffusion equal to charge of hole equal to plus E, that equal to minus d minus dp dou by dou x delta p, that equal to Jp diffusion equal to minus E dp dou by dou x delta p. Here dp is the diffusion coefficient of hole. Next, write the total current density is the sum of current density due to drift and diffusion. The total current density is equal to the current density of due to drift and diffusion. First, we take the electron current density, that equal to Jn equal to Jn drift plus Jn diffusion. Substituting the drift of electrons in previous equation, that is equal to Jn equal to Jn small e mu n capital E plus Jn diffusion equal to E dn dou x by delta n. Similarly, write the equation diffusion of holes, that equal to Jp equal to Jn Jp drift plus Jp similarly Jp equal to Jp drift plus Jp diffusion. Jp diffusion, that equal to Jp equal to P E mu Pe minus E dP dou by dou x delta P. Here the variation of excess electron density delta n with respect to x is drawn. This is the graph for to take the x values. X means on y axis, that is x means distance in semiconductor. Take the y values in delta n, that is the delta n is the excess electron density. Excess electron density. By observing this graph, distance is increases, the delta n values is decreases. Distance is small distance is delta n is increases. This is the diffusion of graph. This name is carrier diffusion.